If you spent any time at all doing software development work, you've almost certainly encountered Git. Git is by far the most commonly used solution for version control, for allowing us to take snapshots of our software development work at various points in time, of allowing us to revert changes that may have been ill-conceived, of allowing us to collaborate with colleagues where we can resolve conflicts that may arise as multiple people try and work on the same software, the same code at the same time. Git is ubiquitous in software development. Unfortunately, it's pretty uncommon for software developers to really spend much time thinking about the internals of Git, how it works under the hood. And that's unfortunate because a lot of the problems that can arise when you use Git really come from not understanding how Git is actually managing your data. So what we're going to do in this video is we're going to start looking at Git, at how we can do version control with Git, and we're going to look at it especially from the perspective of trying to understand what is Git actually doing? How does it work? And so whether you're totally new to Git or you've been using it for many years, I can almost guarantee you're going to learn something new in this video. Now, one of the most fundamental concepts for Git is a commit. And unfortunately, I think there's a lot of people who have used Git for a long time and have never really understood what a commit actually is. And so a big part of what we're going to do right now is to try and make sure we understand what actually is a commit. And so at its core, a commit is going to be a snapshot of the state of our repository at a particular moment in time. So imagine that we've got a repository, a collection of files in a directory that we want Git to manage, to version control for us. And let's say that in our repository, we have two files. One is just a README file. One is a source file called main.cpp. And we'll say that the initial version of these we'll just call version 1, just for our own purposes for this discussion. When you say to Git, I want to commit these files, what it's going to do is, first of all, it's going to take these files and it's going to compress them. It's going to use an open source library called zlib. But the main point is it's just going to compress those files and it's going to store the contents of those files in something called a blob file that is going to be given an ID, a hash, that is some seemingly random collection of letters and numbers. So it might be something like 31AC 15. This one will be compressed, and maybe it's given some ID that is D0 5 1 C, C, E, or something like that. And then Git is going to create a tree. So a tree is basically just a list, a manifest of files along with the location where those files should be. So it's going to reference this hash, which contains the compressed contents of README. And it's just going to list that hash, which contains the contents of the file, along with the name and location of the file. And also, of course, it's going to have a reference to this hash right here, the contents of main.cpp. And that tree is itself going to be given some hash. So something like that. And then Git is going to create a commit. And that commit will itself have a hash. So maybe that looks something like that. And the commit will contain some metadata, information about who made the commit, when it was created, information provided by the creator of the commit in what's called a commit message. And it'll contain a reference to the tree that corresponds to that commit. And this is basically all a commit is. When you tell Git to commit something, it's just taking all the files that currently exist in the repository, compressing them, creating a list of those files, storing some metadata associated with them. If you then modify these files, so let's say that sometime later we've modified main.cpp, and so now we've got main.cpp, but it's some new version 2 with additional features. Then when we commit, Git will, of course, take main.cpp, it'll compress it, it'll put it in some file. But if we've only changed main.cpp, then it's actually not necessary for Git to recompress our README file. So it's only going to compress the files that have changed. And then it will create a tree. Let's say this is tree 2. And maybe that hash is something like this. And this tree for our new commit is going to reference, obviously, our new version of main.cpp, but it can reference our old version of our README file. So in other words, if a file hasn't changed from one commit to another, you can just create a new tree that references the old version of the file, because it's the same thing. Then, of course, we have to create the commit itself. And maybe that's something like this. And this commit will simply reference this tree, but it'll also reference its parent. And so that's really all a commit is. It's just references to the versions of files that existed at the moment in time when this commit was created, as well as some metadata and a reference to whatever the previous commit was. And what we're going to do now is we're going to play around with Git. We're going to create a repository with some files in it. We're going to make a few commits, and we're going to actually open up the internals of Git, and we're going to see the trees, and we're going to see the blob files that Git is creating. And I think what you're going to find is that once you really understand what's going on with a commit, what a commit actually is, you're going to be on much firmer footing for dealing with everything else you need to do with Git. All right, what we're going to do now is initialize a Git repository where we can play around a little bit with Git. And I'm going to just call this my repository, my repo. I'll cd into this directory. And if I type ls, you'll see, of course, there's nothing in here yet. If we want to start using this as a Git repository, then we can type git init. Now you'll need to have Git installed in order for this to work. Look online and you'll find plenty of information about how to install Git on whatever machine you happen to be running on. And then once we've got Git installed, we can type git init. And if you haven't configured Git yet, you may get a warning message like the one you see here that tells you you might want to make some adjustments to your configuration settings, maybe select what you want the initial branch of your repositories to be called. Feel free to do that if you'd like. And in the meantime, let's take a look at this directory again. We'll type ls, and you can see it doesn't reveal anything for us. If, on the other hand, we type ls-a so that we're seeing hidden files, there's actually a directory called .git. And if we cd into .git, you can see there's actually a bit of stuff going on here right now. So this .git directory is actually what git init is creating. It's initializing a directory structure here and some basic files. And when you use Git, when you create commits and whatnot, all of the information Git needs in order to handle your repository's version control, it's all going to go in here. And we're going to take a closer look at what's going on in this .git directory as we proceed. But for now, let's cd back up. This is the top-level directory of our repository. And now we want to create a file. And you can create this file using whatever text editor you like, whatever integrated development environment you prefer. For our purposes, we really don't need much, so I'm just going to use the default text editor for Linux Mint, which is going to be XED, and then I'll give it the name of the file that I want to create. Let's call this file hello.txt. And in this file, let's just type hello world. Then we can close it out. And now we can execute a command that you frequently will use when working with Git, git status. And if we type git status, it'll tell us we're on a branch called master. That's the default name for our initial branch in Git. This message up here is telling us how we can change that if we like. And it's telling us we haven't created any commits yet, which of course is true. And then it's telling us that there is one untracked file, and that file is hello.txt. So what this means is Git, when we say git status, it sees that there's a file called hello.txt, but we haven't told Git that it needs to incorporate this file into the version control work that it's doing. And until we tell it that, it's just going to leave this file alone. It's not going to try and version control this file. It's not going to try and keep track of it as we make changes to it. And so if we want Git to track this file, what we need to do is say git add, and then we can give it the name of the file. If we then say git status again, you can see, well, now it's telling us we have a new file called hello.txt, and this is a change that is prepared to commit. So what this means is now if we type git commit, it's going to create a new commit in which it stores the current version of this hello.txt file. Now, when you type git commit, you generally need to use the -m option for message, and we want to provide a commit message, so just something simple that explains what this commit is doing. And so here we can just say something simple like add a hello message. Now, if I hit return there, it's going to complain to me. And the reason is because if this is your first time using Git, you aren't allowed to make commits until you've provided Git with some basic information about who you are. You need to generally provide Git with, at the very least, your email address and your name. And the reason for that is because any commits you create are going to have that information stored in them. And the reason is because when you first start using Git, you need to configure Git to tell it your name and your email address at a bare minimum. And the reason for that is because whenever you create commits, it's going to store, associated with every commit, the name of the person who created that commit and their email address. And this is important because if you're developing software and you make changes to a code, people need to be able to figure out who made those changes and to be able to contact them if they need help maintaining their code, if there's a problem and they need to contact someone to ask them to fix it. So what we need to do is say git config -- global user.email and then provide it with our email address. And in this case, I'm just going to say you@example.com. But generally speaking, you would want to have your actual email address here. And likewise, I can say git config -- global user.name. And then again, I'll just say your name, but generally that should be your actual name. And I misspelled that, so we'll fix that. All right, now let's try this commit again. So we'll say git commit add greeting message. And this time it actually worked. It created a file for us. You'll notice it says create mode, and then it's 100644. That's because this is a regular file. There's different codes for different types of files that you might be tracking with Git. Directories have a different code. Executables have a different code. That's just something that if you care about, you just have to know what these codes are. And you can see it's giving us this seemingly random sequence of letters and numbers, 6, 7, 6, 8, etc. Well, that is the hash corresponding to this commit. It's actually only part of the hash. We can see the full thing if we type git log. And see, now we've got the full thing right here. This is essentially the ID for this commit. Every time you create a commit, it's going to have a unique hash associated with it. Technically, there's an astronomically small chance that two commits could end up with the same hash, but in practice, you're never going to run into that. And you can also see that this lists our name and email address and when the commit was created, as well as our commit message. So this is the basic information that's going to be included in any commit. And as we add more and more commits, we're going to end up with a much longer git log. It's going to list all of the commits that we've created. Now, here's where I really want us to start getting a sense of what's going on under the hood with Git. So if we type ls.git, this is going to show us again the contents of that .git directory. And you can see within that, there is a subdirectory called objects. Let's take a look inside of that. And you can see we've got a number of directories here, but 3 of them have this apparently random sequence of numbers. One of them is 67, which happens to be the first 2 characters of this commit that we made, of the hash for it. If we then say ls.getObjects/67, you can see that inside of this directory is a file called 68E25, etc. Well, that's the rest of the characters in this hash. So in other words, we have corresponding to this commit a file that is in a directory where the first two characters are going to correspond to the first two characters of the commit hash. And then the file name is going to correspond to all the rest of the characters in this hash. So what's going on there is Git is storing every commit that we make as a file. And the reason why it doesn't just name the file after the full hash, as in 6768E25, the reason why we've got this kind of funny business where we've got a directory with the first two characters, that's just because file systems tend to have trouble if you create too many files in a single directory. And the way that Git is going to get around that issue is it's just going to create all of these subdirectories so that if you've created many, many thousands of commits, the number of files that are going to be in any one directory is going to be less. Now, we can actually look at the contents of this file. If we just say cat.get objects 67, etc., you'll see it just looks like total gobbledygook. And that's because this is actually compressed. So Git will compress all of these files in this objects directory using zlib. But that's okay. We can decompress them using zlib. And one way that we can decompress this is we can use a tool called zlibflate. And this is available in a package called QPDF. So if you're on an Ubuntu-like distribution of Linux, then you could say sudo apt-get install QPDF. So that gives us access to an executable called zlibflate. And we can say we want to uncompress. And then we need that less than symbol there. And then the location of the file we want to uncompress. So that's going to be in get, .get objects 67. And you can see, well, that's basically just what we got out of our git log command. What it says is, first of all, commit. So there's several different types of things that can be stored in our objects directory, one of which is a commit. 175 is actually the length of this file. If you were to count how many characters there are in this file, what you would find is there's 175. It says something about a tree, and then there's a hash. We'll come back to that in just a moment. But then the rest of this is basically just the name of the person who committed the file and the commit message. So it's just your basic metadata. Now, this bit about a tree is interesting. Once again, it has a hash associated with it, the first two characters of which are 5, 8. Notice we have in our .get objects directory a subdirectory called 5.8. And I will bet that inside of that directory, there is going to be a file called 1CAA, etc. So let's take a look. .get /objects/5.8. And look at that. There it is. So there is a file corresponding to this hash. Let's take a look at it. We'll once again use zlibflate. And it's in .get objects 5.8. And it's a pretty short little file here. Once again, it starts with the type of file this is. We saw before we had a file that is a commit file. This one is a tree. 3.7, that's the, once again, the length of this file. these last 6 characters, we saw these before when we committed our hello.txt file. This is the mode of the file. This is just saying it's a regular file as opposed to an executable file or a directory or so on. Then it's the name of a file, hello.txt. And then we've got what seems to be some gobbledygook. So this is actually a hash, much like the other hashes that we've been looking at, except that in this case, it's actually in binary. So even when we uncompress the file, it's not in human readable form. However, I'll just tell you that if we look at .get/objects, you'll notice there's one directory we haven't looked in yet, and that's the one called 98. This gobbledygook is going to be binary, corresponding to whatever file is in this directory. It's the only one we haven't looked at yet. So by process of elimination, we can guess that pretty well. So let's take a look at what's inside of this directory. Once again, we'll use clibflate, uncompress. It's in .get objects 98. And there's the rest of the hash. And first of all, it says blob. So this is not a commit, it's not a tree. What this is the contents of a file. Those are going to go into blob files. 13 is, once again, the number of characters in this file. And this is just the contents of our hello.txt file. Now notice, there's nothing here that says what the name of the file is or where it should be. That information is in our tree file. So the basic structure of a commit is you've got at a minimum 3 things. You're going to have your commit, which is stored in an object file in .get/objects. That file is going to contain basic metadata about your commit, as well as a tree, a reference to a tree. And that file that is being referenced is going to contain a list of files, their locations, and then where you can find the contents of those files. And then finally, for any files that you've committed, you're going to have an object file, a blob file, that is going to contain the full contents of that file. Now let's see what happens if we change this file. So I'm just going to say once again, xcd hello.txt. Let's just open up this file again. And I'm going to add a line that just says, I am learning Git. Let's save that, close it out. Okay, now if we say git status, you'll see it says changes not staged for commit. We have modified hello.txt. So what this is saying is Git is tracking hello.txt. It knows it exists, and it's got at least some version of hello.txt that it's stored in some blob file somewhere. And it notices that we've changed hello.txt since our last commit. If we create a commit right now, if we try to create a commit, nothing's going to happen. So I could say git commit -m, and I'm just going to say this won't work. And you can see it doesn't actually work. It says no changes added to commit. It just sort of gives us the result of git status. If we type git log, there's no new commit here. And the reason is because we haven't actually staged anything. So what I can do is I can say git add hello.txt. Now if I say git status, okay, now git is saying, all right, when you commit, we're going to include the latest version of this file in your commit. See, Git is generally not going to be doing things unless you tell it to do them. So we can say now git commit, and I'll just say that we extended hello.txt. All right, and now if we type git log, you can see we've got a new commit. And this one starts with 0b. Let's take a look in .git/objects. Look at that. We have a directory called 0b. And of course, inside of that directory is going to be a file called cf, etc., etc. This is going to be our new commit. So let's do zlib flate on this. And there's our commit. Now notice it says commit, the length of the commit, there's a tree. Okay, so we could look that up at a moment. But notice it also has something else here, a parent. So commits will track who their parent is. And in this case, it's this commit 67, 68, etc. Look, our first commit is the parent to this commit. Let's take a look at this tree. So I'm going to do zlib flate, and then this time the directory is, of course, going to be 27. And you can see, once again, we've got a tree that's referencing hello.txt. And there's some gobbledygook. What I want us to recognize about this is simply that this gobbledygook is different from the gobbledygook we saw before. This one's got, for example, the letters XRK near the end. This one doesn't have anything of the sort. So this is a different hash. Now, we would have to guess as to what hash this is referencing, but of course, by process of elimination, we can be pretty sure it's the one that we haven't looked at yet, which is D3. So let's take a look at D3. And there, blob 32. And here, what you can see is it's the complete contents of this hello.txt file. So what happens is whenever you create a new commit and there's a file that has changed since the previous commit, what Git is going to do is it's going to take that file, it's going to compress it with zlib, and it's going to stick the entire contents in a blob file, in some subdirectory of objects. The whole file. And then you're going to have a commit that has a tree that lists the version of this file that corresponds to that commit. So this is what Git is doing under the hood. So let's appreciate what Git is doing here. Whenever you create a commit, Git creates a commit file somewhere in .git/objects, and that file contains a reference to some tree file. And the tree file contains a list of all the files that are part of this commit, that are part of this snapshot of our code at one moment in time, with references to the contents of those files at that particular moment in time. And so every time we change a file in Git and we commit it, Git is going to take that complete file and it is going to compress it with clib and stick it somewhere in .git/objects. And so it's got a compressed version of every file at every point where you have made a commit in which that file changed. So in order to drive some of these points home, I've gone to Gutenberg.org, which is a website that stores many public domain books. And let's search for War and Peace. And I'll get the plain text version. And so here is the full text of War and Peace. I'm just going to copy this, and I'm going to paste it in our repository. Let's create a subdirectory called Books, and then let's create a file called warandpeace.txt, and I'm just going to paste the entire contents of War and Peace into this file. We'll save it. And now let's commit this. So first of all, we can do git status, and you can see it's not tracking anything in our books directory. Well, let's fix that. We can say git add books/War and Peace. And then we could say git status again. You could see now it's saying that it's going to commit that file. Notice it's not doing anything with hello.txt because we haven't changed hello.txt. We could say git commit -m, and I'll just say add War and Peace. Okay, so that created a new commit for us, the first two characters of which are 4-5. Well, let's go ahead and take a look at the contents of this commit. So we could say zlibflate uncompress, and then it's .git/objects/45. And you can see, once again, the same structure we expect now out of a commit. There's a tree, and that tree is located at 47 something something. Well, let's take a look at that. And here you can see we've got a little bit more going on than we previously have had in a tree. So we've got, first of all, this regular file called hello.txt, and there's some gobbledygook here, which I will point out is actually the same gobbledygook as we have up there. Notice it's $G, spaces, $G, spaces. So this is actually the same reference. Hello.txt, the contents didn't change, so we can reference the same file. Meanwhile, though, we've got something new here. We've got something with this code. That code corresponds to a directory. It's called books. We've got a reference to it. Okay, let's take a look and see if we can figure out where that's stored. Let's take a look at this directory called 60. And what you can see inside of it is another tree with a regular file called warandpeace.txt, and then there's a reference to it. So this is what was being referenced in our previous tree. it was referencing a tree that corresponded to a directory, which could potentially have multiple files. In our case, it only has the one file, War and Peace. And that file is going to be in a subdirectory called 6A. You can see there's just the full text. Now, let's take a look at the amount of disk space we're using. So let's say DU for disk usage and -H for human readable. And what you can see is that our current directory is of size 4.8 megabytes, while .git is of size 1.7 megabytes. You'll notice that in .git/objects, there's one file that's much larger than the others, and that's 6A. Well, this is the one. This is the directory where our War and Peace copy is being stored. So the compressed size of War and Peace is 1.4 megabytes. And therefore, the total size of .git is 1.7 megabytes. Okay. Let's try making a new commit in which we change War and Peace. So I'm going to open up books/War and Peace. And you can see it takes a while for the editor to even load it. And all I'm going to do here is I'm just going to remove that period. Just a one character change, save it. Let's do get status. You can see we've modified books/War and Peace. Now, something we could do is instead of typing the full name of the things we want to add, we could say get add -u. And what that's going to do is add all of the files that Git is tracking that have been modified but haven't been staged for commit. So we can do that in lieu of actually writing out the full the full path. We can type get status again, and you can see it's ready to be committed. So we can say git commit -m, and I'll just say modified War and Peace. Okay. Now, here's the big question for you. If I type du -h, what is going to be the size of .git? Is it going to be slightly more than 1.7 megabytes? Because after all, we only made a very small change to War and Peace. And of course, Git is just tracking changes to files. Or is it going to be 1.7 megabytes plus another 1.4 megabytes, because what Git is actually doing is it's just zipping up the latest version of the file and then storing it in a new directory. So in other words, is it going to be about 3.1 megabytes? I'm going to hit return. .git is now 3.1 megabytes. Because there is now another 1.4 megabyte file in which we have the complete compressed copy of War and Peace. Because what Git is actually doing every time we create a commit is it takes whatever files have been changed, it compresses them with zlib, it sticks them in a blob file in .git/objects. If you've been using Git for years, there's a good chance that you were under the impression that what Git is doing is some sort of sophisticated thing where it's tracking only the individual changes within each file. It's not. It's just taking the whole file, compressing it, and shoving it away somewhere. And then what a commit is really just a bunch of references to whichever versions of those files are current to that commit. If you thought that Git was doing something sophisticated like this, you probably thought that .git was only going to increase in size by some insignificant amount because we only changed one line. One of the consequences of this is if you're using Git on large files, the size of your repository is going to grow very quickly with commits. Now, thankfully, with software development, we're usually working with large numbers of small files. And so what Git is doing is perfectly sensible for that. But if you're using Git for a wildly different purpose, if you're trying to include image files or something like that, just be aware that could be a problem. That's not really consistent with the design goals of Git. Now, I hope what this has done is to demystify for you what a Git commit actually is. At its core, it's not that complicated a thing. And you can open up .git and you can explore what's going on with your Git history. You don't even need the proper Git commands like git log in order to search out that information. It's just there. It's sitting in the files for you to peruse at your own leisure. And hopefully whenever something goes wrong in Git and you're not quite sure how to fix it, you can just remind yourself that really under the hood, everything that's going on with your commits, it's not that terribly complicated. And most things that you do wrong, you can recover from. Now, of course, that's just the very basics of how Git commits work. In order to be proficient with Git, we're also going to need to understand things like branches, merging, resolving conflicts, collaborating with people. And these are things that we're going to be covering in future lessons in this series. Thank you for your attention. If you found this helpful, if you've learned anything new, then please do consider liking and subscribing. Thanks.